So in the last video, we have seen the formulae for probability of binomial distribution. Is for any particular value of x, we can find the probability using the formula NCX p raised to x into q raised to n minus x. N is total number of trials, p is the probability of success, and q is the probability of failure, and x is the value which has value from 0 to n, and for that value, that particular value, we have to find the probability. Out of n trials, we want probability of x successes. It is given by the formula p of capital X is equal to small x. It is NCX p raised to x into q raised to n minus x. And we will go for examples on this formula. Now we'll go for next example. A pair of dice is thrown 4 times. So 2 dice are taken and they are thrown 4 times. If getting a doublet is considered a success, find the probability of 2 successes. Now, student must guess the clear meaning of doublet. Doublet means on both the dice you are getting the same number, because the student may get confused with the word doublet, that the number on one dice is a double of the second. That is, if 1 is occurring here, 2 will occur here, or if 1 is occurring here, 2 will occur here. If 2 is occurring here, 4 on this side, or 4 is here, or 2 is here, then 4 will be 3, 6, 6, 3. So this is the another meaning of doublet there. Students may take. So if they take this also, but in both the cases, we are getting the same meaning or same number there. When 2 dice are thrown, already we have seen this in 10th standard only, n of s will be 36. So that is 1, 1, 1, 2, 1, 3, 1, 4, like that up to 6 numbers we are getting total. This is 36. And here the event is a such that it is the number with 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And if there is confusion with the meaning of doublet, it will be 1, 2, 2, 1. This is the first 2 numbers. Then 2, 4, and 4, 2. Next 2 numbers, and 3, 6, and 6, 3. Again, you are getting the same. So n of a is equal to 6. Then, so this is the success. And so p will be, probability of success will be 6 by 36. This is 1 by 6. So remember, in this question, the probability of success is not given directly. So first you have to calculate it. It is 1 by 6 then. And q will be, we know that q is 1 minus p. So it will be 1 minus 1 by 6. So cross multiply that 6 minus 1, it is 5 by 6, that probability of success. Here, given n is equal to 4, because you have to throw these 2 dice 4 times. So we are getting n is equal to 4. And we are asked to find probability of 2 successes. We have formula for probability for binomial distribution, and just we have seen this formula in last video. It is probability of capital X, which is the random variable, when its value is small x, then it can be calculated using the formula. It is n c x. N is total number of trials, p raised to x into q raised to n minus x. And so already we have all these values there. N is 4 there, x is 2, p is 1 by 6, and q is 5 by 6. So just substitute the values and calculate it. So probability of x is equal to 2 here. So this is 4c2 into p is 1 by 6 raised to 2 into q is 5 by 6 raised to 4 minus 2 means again it is 2. So 4c2, 2 terms consecutive in decreasing order in numerator, starting with 4, 4, 3, 2, 1 into 1 upon 6, its square will be 1 by 36 into 5 square, again it will be 25 divided by 36. You can cancel 2 here. We can cancel 3 also here. It will be 6. And so we are getting now 25 divided by 6 into 36 to 1, 6. And this is the probability of x is equal to 2. A very simple example we got here. Okay. So we'll go for next example. We'll read the question. There are 5% defective atoms in a large bulk of atoms. What is probability that a sample of 10 atoms will include not more than one defective atom? So we'll go for the solution. Probability of getting defective atom. See here in the question, though we feel that getting defective atom is failure, but for the question purpose, getting defective atom is the success, because we are asked to find probability of that. So probability of getting defective atom is P is equal to, out of 100 possibilities given there, it is 5. So this is cancelling 5 there, it is 1 by 20. And therefore, now we can get the value of Q as 1 minus P is equal to 1 minus 1 by 20. So cross multiply there. This is 20 minus 1, 19 divided by 20. This is value of Q. So we obtain the values of P and Q there. Now, from the question, a sample of 10 items it is given. Here, N is equal to 10 given. And now we have to find the value of X. See the question. What is probability that the sample of 10 atoms, means N is equal to 10 atoms, will include not more than one defective atom? Not more than one defective atom means maximum one defective atom. Means what? Either no defective atoms or one defective atom. So X is, this capital X is or small x is such that it should be less than or equal to 1. And therefore, probability of X is equal to small x, we have this value. This value is given by the formula N of NCX P raised to X into Q raised to N minus X. And here we have two possibilities, that is X is equal to 0 or X is equal to 1. So probability of capital X is less than or equal to 1. This is equal to probability of capital X is equal to 0. This is one possibility. And probability of capital X is equal to 1. Either X is equal to 0 or X is equal to 1. So we'll calculate both here. Now this is using the formula first here. The value of N is 10. So this is 10. C. In the first it is X is 0. P is 1 by 20 raised to X, and X is 0, into Q. Q is 19 by 20 raised to N minus X, 10 minus 0, plus in the second part, N is same, it is 10 C. X is here, it is 1. P means 1 upon 20 raised to X is 1, into Q raised to 19 by 20 raised to N minus X. N, it is 10 minus X is 1 here. So see what we are getting here. 10C0, we know that NC0 is 1. This is, see the numerator, 1 raised to 0 here, it is 19 raised to 10. So I'll write that as 19 raised to 10 is the numerator, and denominator 20 raised to 0 means 1, it is 20 raised to 10. This is 20 raised to 10, plus 10C1. NC1 is N, so 10C1 will be 10 into numerator 1 raised to 1 is 1, and 19 raised to 10 minus 1, this is 9. Now we are getting this is 19 raised to 9 here as the numerator, and denominator 20 raised to 1, and here 20 raised to 9 means total again we are getting 20 raised to 10. So this is the probability. Just we'll simplify it. Now take the common terms outside there, outside the bracket. From the numerator, 10 raised to 19 raised to 10 is there, and 19 raised to 9 is there. So we can take 19 raised to 9 common outside from numerator, and denominator 20 raised to 10 is taken outside. So what remains there is from first term only 1, sorry, it is 1 into 10. So 10 remains there because 10, 19 raised to 9 is taken outside. And from second, 19 raised to 9 is taken outside. So 10 will remain there. Here it is. 19 will remain. From first term and second term, 10 will remain. And so the probability of capital X is less than or equal to 1 is given by, this is 19 plus 10 is 29 into 19 raised to 9 divided by 20 raised to. So this is the answer. So we'll go for the next question. 5 cards are drawn successively with a replacement. First card is drawn, noticed, and again kept back. Then second card is drawn like that with a replacement from a well-shuffled pack of 52 cards. Find probability that, number 1, there are 3 sub-questions. Number 1, all 5 cards are spade cards. Spade is pick. The second, only 3 cards are spade, remaining maybe in any type. And third, none is spade. So we'll see how to solve this. Out of 52 cards, there are 13 spade cards. So we'll find the probability of getting spade card. So P, probability of getting spade card. Spade card is, now this is the probability of success, P. It is 13 out of 52. Means simply we are getting, this is 1 by 4, and therefore Q is equal to 1 minus 1 by 4. This is cross multiply, that is 4 minus 1 is 3 by 4 here. So N is equal to, N we have to draw 5 cards. So N is equal to 5 here. And the formula for probability of capital X is equal to small x is NCX P raised to X into Q raised to N minus X. This is the formula. Now we'll go for the first sub question. It gives the values of small x there. All 5 cards are spade. Means small x is equal to 5. This is very simple. Use the formula first there. By first, probability of capital X is equal to 5 is NCX. N is 5. C, X is also 5. P is 1 by 4 raised to X is 5 into Q is 3 by 4 raised to 5 minus 5. Now this is N minus X, 0. So 5C5 is 1 into 1 raised to 5 is 1 divided by 4 raised to 5, 1 6, and it is multiplied by 4. It is 1024. 256 into 4 is 1024. Into this is 3 by 4 raised to 0. This is 1. So probability of capital X is equal to 5 is 1 divided by 1024. And this is the answer of the first question. Now we'll go for the second. Here only 3 cards are spade. So we have to consider X is equal to 3 here by first. So probability of capital X is equal to 3 is. Now N is 5, C, X is 3, P is 1 by 4 raised to X, X is 3 into Q, this is 3 by 4 raised to N minus X, N is 5 minus X is 3. So this is 5C3 means 3 terms in the numerator, 5 into 4 into 3, these are the consecutive decreasing terms, divided by 3 is there, 3 into 2 into 1, consecutive terms, 3 gets cancelled with 3, 2 here with this 2 into 1 raised to 3 and 4 raised to 3 into 3 raised to 2 divided by 4 raised to 2. So we are getting this is 5 into 2 is 10 into 3 square is 9 divided by 5 raised to 3 into 4 raised to 2. So again this is 1024. You may cancel the term of 2 there. This is 5. This is 5, 1, 2. And so we are getting it is equal to 5 into 9, 45 divided by 5, 1, 2. This is probability of capital X is equal to 3. And so this is the answer of the second question. Now we'll go for third sub question. It is capital small x is equal to no spade cards. X is equal to 0 by first. Probability of capital X is equal to 0 is, now this is 5c, x is 0, 5c 0, 1/2, 1 by 4 raised to x is 0 into 3 by 4 raised to, now this is 5n minus x is 0. So 5c0 is 1 into 3 raised to 5 divided by 4 raised to 5. 3 raised to 5, this is 3 raised to 3 square is 9, x square is 81 into 3. It is 243 divided by 1024. And this is the answer of the third sub question. We'll go for the next question. A bag consists of 10 balls, each marked with one of the digits from 0 to 9. And if 4 balls are drawn, that is n is equal to 4 here. If 4 balls are drawn successively means one after another with replacement. First is taken, the number is noted, when it is kept, then second is taken, the number is noted, like that. We have to remove, take 4 balls. If 4 balls are drawn successively with replacement from the bag, what is the probability that none is marked with the digit 0? That is, all the numbers, all 4 numbers must be non-zero. So we'll go for the solution. N is equal to 4. P is probability of number is 0. So P will be equal to, out of 10 balls, only 1 ball has chance of getting number 0. So probability of P will be 1 by 10. And so Q will be 1 minus P. This 1 minus 1 by 10. This is 9 by 10. This is the probability of failure. And here you are given total 4 chances. And the probability that none is marked, that is here, we have to consider x is equal to 0, because you have to draw ball 4 times and out of that you must get 0 successes. So n is 4 and x is 0. We have probability of a random variable x for the value small x is given by NCX p raised to x into q raised to n minus x. I'll call this as first. And we have all the 4 values p, q, n, and x. Just put the values there and get the answer. So you get probability of x is equal to 0. Now n is 4, 4c0, p is 1 by 10 raised to 0, and q is 9 by 10 raised to n minus x, 4 minus 0. So we have 4c0 is 1 into any number raised to 0. This is also 1 into 9 raised to 4 divided by 10 raised to 4. And 9 raised to 4. 9 square is 81. 8 square is 6. 561 divided by 10 square is 100, its square is 10,000, and so probability of x is equal to 0 is 0.6561. So when we draw 4 balls successively after replacing back, then the probability of not getting 0 is 0.6561. So that's it for this example.